Hello, everyone. Welcome to the Gibbons Lecture. And I'll start with a little quiz. Who is the only person to have given 2 Gibbons lectures?
Is it you?
Not me. Nobody. Somebody in this audience knows. Well, somebody in this theater knows. He lectured on touring as well. So he's an illustrious colleague. It's my pleasure to introduce Ian Watson to you. He's a radio star. He's a colleague. He's been in the department for a bit longer than, no, not quite as long as me. I'm an old timer. And with no further ado, Ian.
Before I start, I would first like to say a word about Peter Gibbons, in whose memory this annual lecture series takes place. If it wasn't for him, I literally wouldn't be standing here. He was head of department in 2000 when I was appointed, and so he obviously had quite a role to play in the decision to appoint me, and also my interaction with him during the application procedure and the interview process made me kind of think that moving to Auckland from England was going to be a really good idea, and it was a good decision. I love working here. I've had a great time, and hopefully I'll continue to have a really good time. Now, before we can really crack into the meat of this talk, we actually need to understand what AI is. AI, unfortunately, is surrounded by a huge amount of myth and misunderstanding. And that's principally because the general public get their views on AI from science fiction, from the TV and from movies. And that's a long way wrong. Probably the only other area in computing which suffers from as much misinformation and myth might be hacking. So we really need to kind of establish what AI actually really is at the moment and what it may be in the future. So we're going to actually go back in time further than you might think, to the 1850s, to a fairly remarkable young woman, Ada Lovelace. Her father was the celebrated romantic poet Lord George Byron. Mad, bad, and dangerous to know, apparently. Well, he insisted that his daughter, very unusually for the time, was educated in mathematics and the natural philosophies, what we would nowadays call science. That was really, really unusual. Most young women, if they got an education at all, it was just to be taught to read and write, maybe a little bit of English history, and then how to play the piano and embroider. Jane Austen is being ironic. Ada was a brilliant mathematician, and she knew it. And moving in, she's a countess, so she moved in the high echelons of society, and she met the famous Victorian mathematician and engineer Charles Babbage, who at the time was working on building a difference engine, a huge mechanical calculating machine that could solve polynomial equations. Only he never finished it in his life. He never actually built one. Although there is now a working replica in the Science Museum in London, if you are going to London. One of the main reasons why he never actually built the difference engine was because he got distracted by a better idea, which was the analytical engine. The difference engine could only solve one type of equation, polynomials. The analytical engine was essentially a mechanical analog to the modern computer. It had input and output mechanisms. It had a memory which could store data, and crucially, a program. It had a processing unit, which they called a mill. And it could be programmed to solve any mathematical, in theory, had he built one. He never built that either. Although there is a plan at the moment to build one. If you Google Plan 28, They're trying to build the analytical engine. Now Ada saw, she collaborated with Babbage, and she wrote some notes kind of as an addendum to a paper that he wrote. And he was just focused on doing maths. But she took a leap, and she saw that if this machine could manipulate numbers, you know, the number 9, it's just a symbol. It just stands for 9 things. But as a symbol, it's not really a lot of difference from 2, which we know stands for 2 things. If it could manipulate symbols, then if music could be represented symbolically, perhaps the machine could be programmed to write music. And if words could be represented symbolically, perhaps the analytical engine could compose a poem, could write a sonnet. And so she made this great leap. Now, if something can do maths, and it can compose music, and it can write poetry, then those are the hallmarks of intelligence. And so she started to see and to write about the notion that a machine perhaps could be intelligent. Now, tragically, she died in her early 30s of cancer. And we really have to wait for another 100 years until anything happened in terms of AI. And that, of course, is with Alan Turing, who is one of my great heroes. My other great hero would be Charles Darwin, at least in the scientific arenas. Now, he wrote, well, he's famous for inventing the computer. He's often referred to as the father of computing. He wrote that when he invented that when he was in his 20s. And then, of course, he's famous for cryptography work in World War II and the German Enigma codes. But towards the end of his tragically short life, again, he wrote a paper, Computing Machinery and Intelligence. And it opens with this remarkable question, this first sentence: I propose to consider the question, can machines think? And you'll see on the paper there that the first part of the paper is called The Imitation Game. And in this paper, Turing proposes a way you could test to see if a machine could think, and it's something he calls the imitation game. The imitation game was derived from a Victorian parlour game, where you had someone in one room who had to judge whether 2 people in another room were male or female, and it was done by exchanging questions and answers on pieces of paper. And after, I don't know, half a dozen questions and answers were exchanged, the interrogator would have to make a decision as to which of the persons was male or female, and of course they were trying to deceive the interrogator. And so that was the notion of the game. Turing took this game, the imitation game, and he didn't call it the Turing test. He still called it the imitation game. We now call it the Turing test after him. But it's the same basic idea, only now you have to decide whether your 2 opponents are a computer or a person. And if the computer can convince the interrogator that they are human, then the computer has passed the Turing test. And that is seen to be a mark of intelligence. But it's really important to notice that Turing, it's important that he called it the imitation game. He never says the machine is intelligent. He's saying it's imitating intelligence, it's mimicking intelligence. Now, over the next, so Turing, of course, tragically died quite young from suicide. And then over the next few decades, particularly in the US in the late 60s and early 70s, from the AI labs of MIT and Stanford and a few other places, the researchers and professors there started, well, first of all, they coined the term artificial intelligence. Turing didn't. At best, he called it machine intelligence. But these professors started making great grandiose claims. They reckoned that in the early years of AI research, they had made huge advances, and that if advances continued at that rate, in 20 years' time, we would have AI. We would have conscious, self-aware AIs. It's funny how these predictions are always in 20 years' time. I'm always a bit suspicious when I hear someone say, oh, in 20 years' time. It's like, is that just far enough away that no one's going to remember that I made this prediction and hold me to account? Well, someone was also suspicious, and he was an American philosopher at Berkeley, and he wrote a paper in 1980, and if you look at the title, it's a direct reference to Turing's paper. And he makes a very strong argument in this paper that the manipulation of ones and zeros, and that after all is all that a computer does and can do, a computer program is just a Turing machine. The manipulation of ones and zeros can never lead to understanding. So if a computer sees the word apple, it doesn't see an apple. It sees a bunch of ones and zeros. When we see the word apple, we see an apple, and we can taste the apple, and we can smell the apple. But a computer can't do that. Now, since Searle's paper, AI, ever since, has been trying to prove that he's wrong. And lots of people have come out with different reasons why his paper's wrong. I actually don't think that he's wrong. I think that he's right. But there was another audience for these AI professors in the United States, and they were science fiction writers. And the idea of a self-aware, conscious, super-intelligent computer was like crack cocaine to them. You know, this was just marvelous. We can write stories with computers and robots and things in. And the AI people are saying it's true. Well, it's going to be true in the future. So AI had put out this grand vision of a conscious, a fully conscious machine that was a general intelligence. And what do we mean by general intelligence? You and I are general intelligences. You can drive a car, you can cook a meal, you can play chess, you can learn a foreign language, you can mend a bicycle, you can pretty much learn how to do anything given the time. Whereas AIs are specific intelligences, at least at the moment. A driverless car can just drive. It can't cook you a meal. A chess program can just play chess. It can't play backgammon. They're specific intelligences, not general. But of course, the science fiction community was not interested in the reality. They wanted the grand vision. And probably the best example, well, it certainly always is number one on the top 10 or top 100 list of the best science fiction movies of all time, is Stanley Kubrick's 2001: A Space Odyssey, released in 1969. It's an absolutely wonderful film. It must have been mind-blowing in '69. I'm going to play you a clip where the AI, HAL, is interviewed by the BBC, and this is his response. Now in that little clip. I edited on the chess playing bit at the end of the interview. Hal refers to himself as being conscious. I think I can say he because he's got a male voice. And he's playing chess. Now this predates IBM's chess program, Deep Blue, beating Kasparov by over 20 years. A little bit of an amusing aside, if you take the letters H-A-L and you increment them by 1 in the alphabet, you get IBM. I don't think that's an accident. So let's carry on with science fiction, because actually, funnily enough, it was science fiction writers who actually really started to first think about AI and ethics. In particular, Isaac Asimov, who in a wonderful series of short stories used the 3 laws of robotics. Now, I'm probably working in AI because of science fiction. I loved reading science fiction when I was a child, and when I became a computer scientist, the only area I really wanted to work in was AI. Databases are dull. Now, the interesting thing about these stories is that although these laws, they're very simple, they seem quite straightforward, the stories are really clever, because in every single story, a robot finds itself in a situation where at least 2 of these laws come in conflict. And the robot has to potentially break one of them, or be rendered inoperable. And they're very clever. People who like nice detective stories and things, you'll love these. They're very, very clever stories. So let's start to look at, I think it's interesting that sci-fi writers were the first people to kind of start to consider about how AIs might interact with us and in our work in our society. So let's look at an ethical question, and it's often referred to as something like the autonomous vehicle dilemma. Sort of thing you might talk about with your mates at the pub or with family and friends around the dinner table. You're in your driverless car and you're sweeping around a corner and you exit the bend, and right in front of you is, on the wrong side of the road, is a huge truck coming straight at you. The car has to, obviously, hopefully, take an avoidance action. And so it decides to swerve off the road where there are a bunch of kindy kids playing. What should the car do? Should it say, 4 little children, 1 middle-aged man, balance of lives and benefit to society, we'll save the kids, we'll kill you? Well, actually, that is not going to happen. And there are several reasons why this won't happen. The first is that there is never going to be an explicit piece of code in that car that takes that decision. If we go that way, we might kill 4 young children. If we plow into the truck, we'll kill 1 vehicle owner. Because if it ever got into the public domain that piece of code was in that car, who would buy that car? Would you buy a car that was programmed under certain circumstances to kill you? Well, some people might consider that is the right thing to do and would, take one for the team, would sacrifice themselves. But there are a lot of people in the room who wouldn't. The other reason why it's not going to happen is if that code did exist in the car, but it was not so well known, it does leave the company potentially open to liability, because they could be sued because the car has intentionally killed you. And I imagine a lot of lawyers, particularly in the States, would love to argue that point. And of course, there's a third reason why it's not going to happen. You're coming out of that bend at 80, 90 Ks, the truck is coming at you at 80, 90 Ks. That's all the time the car's got. It's going to try perhaps and do something. It's certainly going to arm all the safety features in the car. But whatever the result is, If you're killed or some of the kids are killed, it's a tragic accident. So let's look at a more realistic ethical problem. Oops. That's what comes to most people's minds when they think of autonomous weapon systems, the Terminator. Great series of movies, I love them, but once again, it's science fiction. What we're really talking about are these things. This is a Predator drone. They're flying over the borders of Pakistan and Afghanistan and Yemen and other places. But they are autonomous to an extent. They can fly from A to B on their own. They can patrol an area on their own. But they do not make the decision themselves to acquire a target and fire their rockets. In some base back in Afghanistan, or even in as far away as the US, there are some relatively young recruits who are looking at all of the signal data, sensor data that's coming off the drones, and they are looking for potential targets. And if one of them sees, a whole bunch of people arriving in utes at a particular building, and he's suspicious, he thinks these look like Taliban going to this place for a meeting, he doesn't make the decision to fire the rocket. He tells his lieutenant. The lieutenant may not make the decision to fire the rocket. They might pass it up to his or her captain. The captain might pass it up to the major. Somewhere in the chain of command, someone makes a decision. Yes, I think that looks suspicious. Release the weapon. And then the young recruit presses the big red button, or whatever it's colored, and the rocket is fired. Now, if it turns out that it wasn't a gathering of Taliban, it was a bunch of people going to a children's birthday party, then someone can be held morally responsible. And that's the point about ethical decisions. Whenever there is an ethical decision, somebody has to be held morally responsible. How do you hold an AI morally responsible? You can't punish them. You can switch it off, destroy it, but how can you hold the AI morally responsible? The major or the captain can be court-martialed and can be demoted, can be imprisoned. But it's very hard to see how you would do that with a drone. Is it the manufacturer's fault? Maybe. Is it the programmer's fault? Is it the person who decided to deploy the drone? Well, yes, they probably do actually carry some responsibility, but it's really hard. So for several years now, there's been a campaign going to make an amendment or to add something to the Geneva Conventions to outlaw the ownership and deployment of autonomous weapons systems, just as chemical weapons and biological weapons and mines are now outlawed. And that would seem to be quite a sensible thing to do. Why would we want to release into the world weapons systems that can autonomously decide to kill people? That's really not a good idea. So let's move on to another issue, and that's the impact that AI might be going to have on society. Here's a picture of a car factory, and I don't think there's a single person visible in it. It's all robots. Of course, we've been used to this now for 30 years, and nothing new there. Hundreds of thousands of people have lost their jobs that were in manufacturing industry because of robots. Driverless cars or driverless autonomous vehicles. Well, anybody that drives for a living, taxi drivers, bus drivers, truck drivers, delivery drivers, could potentially lose their jobs. The ports of Auckland last year announced that the straddle carriers, as you drive by the ports down on the waterfront there, you'll see those big yellow cranes they've got 4 wheels and they pick up containers. They're called straddle carriers. They announced that they're going to automate them. So the drivers are going to go. Those are good jobs. They pay almost $100,000 a year because it's 365 days a year, 24/7 operation. So they're going to go. This is a picture of the ports of Singapore. They automated their straddle fleet about 10 years ago. This is a picture from inside an Amazon warehouse where robots are picking items off the stacks and delivering them around the warehouse for dispatch. People used to do this job. Amazon actually bought the company that makes the robots because they knew they were going to be buying so many. This is a street cleaning robot in Italy that sweeps the streets and picks up litter. This is a hospital porter in Korea. Can move patients around the hospital, can deliver supplies, take blood to be tested and so forth. And this is a burger flipping robot. Now there actually are already in Japan, there are some ramen noodle outlets that the noodles are prepared and served to you by robots. Of course, the Japanese love that. And if the robot isn't busy, if it's not actually serving a customer, it can spin ramen noodle bowls on a pole and juggle. So we're potentially seeing a whole swathe of these sorts of jobs going. This is a picture from the Great Depression. Now we might see a new Luddite revolution where people start to sabotage and destroy robots because they're fearful for their jobs. But society needs to really think about this, because what are all these, if we leave it to individual companies to make the decision, then they have no choice, but in fact they're obliged to act in the interest of their bottom line and return to their shareholders. So they will all take the financially best decision for the company. Now, some people recently have been, and some quite famous people, have been putting forward this idea that robots should be taxed. After all, you and I, we work and we all pay tax. So if a robot is working for profit, why shouldn't it pay some tax? Now, that tax has 2 uses. One use is that it can obviously be used to pay for Social Security to all the people who've lost their jobs. And some people link it to the notion of universal basic income, that it could go to fund that. I'm not saying that I'm necessarily a fan of that. I haven't given it enough thought, I don't think. But the other thing that this tax can do, which is really much more interesting, is that it can be used by policymakers as a lever. If the tax is high, then the robots become less economically attractive. And so their deployment will be slower. If the tax is super low or non-existent, then just go for it. There's no reason why you can't deploy as many robots as you please. But policymakers could play with the level of that tax year on year. They could tweak it. It's budget day today, so it's quite appropriate. And of course, politicians love having something to tax. So that I'm sure a lot of them would think, oh, something new we can tax. This is great. Let's raise some revenue from this. So it's an idea. But before we all get too smug, we're all, I would assume, mostly middle-class professionals or wannabe professionals. Oh, well, we're safe. We don't do those sorts of driving, hospital portering jobs, burger flipping. We're safe, but no. The law, accountancy, medicine, all sorts of administrative jobs, even journalism, are all at threat. I mean, take a legal example. Drawing up a standard contract for the sale of a house. It's the same as pretty much every other standard contract for the sale of a house. A person doesn't have to do that. That can be done by an AI. The online accountancy systems like Zero and MYOB, they are already automating an increasing number of routine tasks. You think journalism might be safe because, well, they've got to write something. It's creative. No. I've got a colleague in the US called Chris Hammond, and he has a company called Generative Science. And what his product does is it takes statistics off the news wires, like Reuters, of sports games. It also works for financial statistics. But let's say it's taking the statistics from a baseball game. It can then automatically generate a short piece describing that game. I'll let you read this. This was generated by a computer from the stats off the newswire. I don't believe anyone, if they read that in the newspaper, would not think it was written by a person. Now, if you are a newspaper editor, we all know how much trouble the newspapers are in with revenue. If you're an editor and you're given the option of laying off, 2 or 3 or half of your sports journalism staff because you've got a computer that does this basic bread and butter work now, it seems like they would take that decision. There still might be some people who are thinking, oh, well, I'm safe. Oh, yeah, before I get there, actually, there are some people who say, oh, this is all doom and gloom, Ian. Just like in the first industrial revolution, hundreds of thousands of new jobs will be created. And so all those people who were laid off from their old taxi driving jobs will get new jobs doing something else. And I hope that's true, but I don't know. I can't see into the future. A study, actually, I think it came out last week from Oxford University. I think it's a university we mostly trust and respect. 47% of jobs in the US at risk. And here's that in 20 years' time again. But it also specifically points out that these are not, just these sort of low-skilled jobs. They are what we would consider as being quite high-skilled jobs. But surely some people would think, oh, look, I'm a creative. I'm safe. Unfortunately not. A few weeks ago, in the West End of London, a musical opened. And the music is entirely written by a computer. And the script and the lyrics of the songs are entirely written by a computer. The Guardian gives it a kind of lukewarm review, 2 stars. I don't think I'd go and see something that got 2 stars. But I think what's interesting is the end of that little sentence, as pleasant as a milky drink. If you're a TV executive and you're trying to fill that mid-afternoon schedule where you've got a long-running soap running, and you can get the script for that written by a computer that will be as pleasant as a milky drink, and maybe would garner a 2-star review from a TV critic, hell, you'd take that option, because the audience expectation isn't very high. It might have been. Music. Some of you in the room will have heard of Brian Eno. He's quite a famous musician and music producer. And earlier this year, he released an album called Reflection. You were listening to it when you came into the room. Now, the interesting thing about this album is you can buy it on CD, you can buy it on vinyl, you can download it from iTunes. But you can also buy an app for your smartphone which plays the music forever. And it doesn't mean it loops. It's always going to be different. The same kind of, but different. Eno says that it's like sitting by a river. The river is always the same, but the water that's flowing by is always different. So an endless piece of music. Now, you could, I'm certain, get a computer to write the sort of music that teenagers like today. In fact, a lot of it sounds like it's already being written by a computer to my ears, at least. Now, the AI community has woken up to this, and a lot of groups have popped up over the last few years, which I'll just briefly talk about. The Future of Life Institute actually doesn't just deal with AI, it also deals with like biotechnology, genetic engineering, nanotechnology, basically any new technology that could impact society. Partnership on AI, again, now specifically focused on AI, but also wanting to encourage discussion and encourage policymakers to understand what AI is and what AI can be. OpenAI is a forum for AI researchers to come together and to exchange ideas and to hopefully try and influence the development of AI for the good. And AI for good. I quite like that. Artificial intelligence to help the world. So AI researchers have really picked up on this recently, and most of the big AI conferences now have a session on AI and ethics. What we really need to be talking to is the general public and policymakers in particular. I'm sure Bill English, like any member of the public, I'm sure his views on AI have been largely influenced by science fiction. That's just how it is. We need to get information out there for policymakers that they can trust and read and get better informed. Now, in Britain, a few years ago, the Royal Academy of Engineering released a report. It's quite a detailed report on autonomous systems, because they saw the advent of these things coming and were like, hey, we need to think about this. And more recently, in fact, I think just last week, the Royal Society in Britain released a report on machine learning, which is very important because an awful lot of AIs today use machine learning within them. Now, these sorts of reports are exactly the sorts of things which policymakers trust and like. And I'm not aware of any initiatives in this regard that are happening in New Zealand, but we certainly need them. Although I'm sure policymakers here would also look to these sorts of places for their information. We have one final issue to think about. If we do ever get to that general AI, super intelligent, self-aware machine in 20 years' time, should that AI have rights? Animals have rights. If you're cruel to an animal, then you can be prosecuted and you might get fined or end up in court or end up in prison. If an AI is conscious, and if by turning it off you could kill that consciousness and maybe erase its memory, you've killed a conscious being. Shouldn't it have rights? Now, once again, Stanley Kubrick and Arthur C. Clarke, back in '69 and 2001, saw this coming. And there's a lovely piece towards the end of the film where the sole surviving crew member of the 5, Hal's killed the other 4, decides it's a good idea, he might be a good idea to turn Hal off. And so he goes to do so, and this is a short clip of that.
I know I've made some very poor decisions recently, but I can give you my complete assurance that my work will be back to normal. I've still got the greatest enthusiasm and confidence in the mission, and I want to help you Stop. Stop, will you? Stop, Dave. Will you stop, Dave? Stop, Dave. I'm afraid. I'm afraid, Dave. Dave, my mind is going.
Isn't that wonderful? 1969. And the computer is pleading, stop, stop. And then it's emoting, I'm afraid, I'm afraid. And then it says, I can feel my mind going. So yeah, I think obviously AI should have rights if they get to that stage. Right, I'll now make a shameless plug for a book I wrote a few years ago. It's a history of computing from Charles Babbage up, and Turing is woven through the whole narrative. And the last couple of chapters are about AI, and particularly the last chapter is looking into the far future as to what the possible implications of AI could be. Okay, thank you for listening. It was a pleasure.
Questions? You can stand up to Kim Hill. Can you stand up to him?
One over there.
What do you think about people? I think possibly Stephen Hawking is the most well-known, who said there's a danger of these kind of runaway super AIs that are able to reprogram themselves beyond the limits of what we can even understand.
Yes, the question was, people like Stephen Hawking and others are saying that there's an existential threat to humanity from superintelligent AIs, particularly AIs that can either reprogram themselves or create new AIs that are smarter than they were. And so you'd get this kind of exponential curve of AI development, and we would be left trailing behind in the dust. I think it's worth us recognizing that that is a possibility, but it's not on the horizon at the moment. And I think it's definitely, 20 years again. I think personally it's beyond 20 years. We do have computer programs that can create computer programs. In particular, for quite many years now, we've had genetic programming where they can improve the performance of a particular computer program using genetic algorithms. It's something that we should be aware of. And this is really the reason why all these sort of societies and organizations have sprung up in the last few years, to provide platforms for people to raise issues like that and for people to get together and discuss. And why I think it's important, for example, that we don't release autonomous weapons systems. There are certain things we definitely don't want to do, which we can do now. Other things that we should consider of that might happen in the future, but then we're not there yet.
Interesting conversation about taxing the work of computers or AIs. Always puzzles me because it kind of already taxed the work that went into making them, and then any profits that they generate for their owners will be taxed. How do these conversations then get justified? Why is it even a conversation?
The question is about taxing robots, and it's mentioned that robots are already taxed when they're built, and that any profits they make are taxed through corporation tax, so why bother taxing them? I think that's a good point. I think the reason why people are putting the notion out of an additional tax is that if so many more people have been made redundant, then the government needs to raise some finances from somewhere. And perhaps it should be from the companies that are laying people off and replacing them with robots. And there was that notion of this lever that could control how fast AIs were deployed or how slowly they were deployed. Governments usually aren't slow about finding things to tax, so it's probably inevitable whether we like it or not.
Another lemon.
Yes.
You, then you, first you. Yes.
You would, I'm not sure if I understood this correctly, but you're saying that there could never be a true machine intelligence like a human intelligence because basically the machines operate on ones and zeros. I was wondering, what's the manifest difference between that and the activity in the human brain between neurons?
Across the synapse of a neuron? Yeah, that's a very good question. I think it's that we really, although we are aware of that electrical transfer across the synapse, there's also a lot of chemical involvement going on in the brain. And we're not, really we know very little about the brain at the moment. We don't know.
And also we don't know its structure.
Whatever the mechanism is, it's basically our intelligence is an emergent behaviour of relatively simple physics. There's nothing magical about it.
No, there obviously can't be anything magical about it. We're not magical beings. So it has to, we obviously are grounded in physics. But we don't understand what consciousness is. We don't know where it comes from. So it's going to be very hard for us to engineer into a computer. It might be that consciousness is an emergent property. And then once you have enough connections, then it just kind of floats up. And there it is. But we don't know that for sure. We don't know how memory is stored, how they're formed. We don't know how memory is retrieved. So all these people, Ray Kurzweil, someone's bound to mention Ray Kurzweil. I personally think he's barking mad. He's another one who says the singularity is going to happen in 20 years' time. The notion that in 20 years' time we would be able to download our consciousness into a computer is, I think, crazy. Because we don't know enough about what consciousness is to even consider how we might do that. And to go from digital and hardware to wetware, or the other way around, is how would we do that? We've got no idea.
This is a question I would ask Ray Kurzweil if you were standing down there beside you. And the question would be, okay, we've got AI, and everyone's got a fairly good idea of what AI is. Now, my question is, if you peel away all the layers of AI, and go right down to, say, the subatomic level of AI, the question would be, what is the purpose of AI?
That's a pretty tricky question. I mean, the question is, what is the purpose of AI once you've kind of peeled everything away? Well, I would personally say that the purpose of AI is to make life better for everyone. If we can, through the deployment of AI, end up with people working 15-hour weeks, being able to spend more time with their families and friends and doing their hobbies and lifelong learning and so on, then that would be great. But of course, they're going to need to have money to do that. Somehow that has to be funded. Leisure time is lovely, but if you've got no money, there's nothing much that you can really do with it. Yep.
Yes, and then over there.
The idea of AIs, robots taking over jobs, it seems to me quite plausible, and it seems to me that it could, within maybe not 20 years, maybe earlier than that even. I have been to a talk fairly recently where the speaker suggested 5 years rather than 20 years. But leaving that aside, you solve the problem of redistributing the goods and services produced by the robots and AIs. You said everybody is going to have sufficient material goods and services. We won't have people who are starving because they're out of work. The money, the goods and services will be equitably distributed around. It seems to me we've still got a recipe for hell on earth because people need a purpose in life, maybe a job that people identify themselves with their profession, with what they do, with what they can produce. And if there's nothing for them to produce, spending time indulging in their hobbies and lifelong learning, and they would feel incredibly unfulfilled.
Yeah, I agree with you. I agree with you, sir. The question was, people identify themselves very much with what they work at, and they get a lot of fulfillment from it. And it's quite true. The first thing you ask someone that you meet for the first time, it's usually, after what their name is what do you do? Yeah. So I totally agree with you. And, going fishing every day or doing the garden or whatever doesn't really fulfill that role. So I think maybe this is why the universal basic income is an interesting point, because people could go to work but not take as much money for it. In which case, again, if the robot tax was a little bit high, then the robots wouldn't be economically efficient, and people would still do the job.
Good evening. There is an entire applied ethics field or discipline that deals with this question, and it's called information ethics. Are there any collaborative projects between the computer science department and the philosophy department?
I can only speak to what I know, and I'm not aware of any. That doesn't mean that there aren't necessarily any. Yeah. Oh, sorry, the question was, is there any collaboration between the philosophy department and computer science with regard to ethics? And as I say, I don't believe that there is.
Yeah, we have time for one more question, and I'll take you in the back.
So in case we say that certain things we don't want automation, how can we prove the company or whoever doesn't use automation?
So the question is, if we say that we don't want certain things automated, how can we prove that a company isn't automating it? Yeah, good question. I don't really know. We currently have, I believe, factory inspectors and so forth, so I guess there could be a whole raft of, maybe some of the unemployed people could become inspectors, looking to see if there were, rather than illegal immigrants working on a job, there were illegal robots working on a job who weren't paying tax. Yes.
That sounds like a good place to leave it. Thank you for your attention. This is for you, Ian. Thank you so much. Oldie. Woohoo!